Now, in this video, we will going to consider one program, how to develop a program to generate Fibonacci square of length capital N, where read the capital N from the console. So what exactly we mean the Fibonacci series? A Fibonacci series is the one wherein you have to add the sum of the two consecutive numbers is added together to get the third number. Once you get that, the sum of the last two numbers are added together to get the next number. So every time it keeps on adding the two numbers to get the third number. So in this way, we will be able to get the Fibonacci series. But since he is asked for the Fibonacci square, so that means every number is squared and whatever the value you get, that is the one which you need to give. The sequence will going to be the same. First, what I need to do is I have to obtain the Fibonacci series sequence. Once you get the Fibonacci series sequence, later on we are squaring the each number so that you will going to get the Fibonacci square. So how to do that? So first we will going to write a code. So we have defined a function. So what is that? The Fibonacci n, where n is the parameter. So we are taking the n number. So that means I have to give the number of sequence or the total number you want to find the Fibonacci of that length of the number. So initially what we are doing is I am considering one Fibonacci series having two numbers. So these are 1 and 2. I am initializing that 0 and 1 are the Fibonacci series. So now we are applying the condition. Why we need to apply the condition? See, basically because we have a sequence of numbers, it is iterating through. So that means one number is there, second number, then I have to get the third number. The sum of these two will going to give the third number. The sum of the second and third will going to give the fourth number. The sum of third and fourth will going to give the fifth number, and it's so on. So this is how it will going to go about of doing that. But what is the length I want? Suppose if I take the total number is 10. So the Fibonacci sequence will going to be up to the 10 numbers. So every time it should add the last two numbers of the list. So since you have to add the last two numbers of the list, so I need to iterate every time. So for that I'm going for a while loop. So this is a list containing the two numbers 0 and 1. So what is the length of this Fibonacci series? The length of the Fibonacci series at present is 2. Why? Because you have 0 and 1. While length of the Fibonacci series is less than n. What is n there? N is 10. What is the length of the Fibonacci series? At present we have the two numbers initially. So is 2 is less than 10, condition is true. What will going to be the next number? The next number will be Fibonacci series minus 1 and the Fibonacci series minus 2. So which is minus 1 and minus 2? So when you are going from this is what is called negative indexing. So when you are going for the negative indexing, we have to start from right towards left. When you are going from the left towards right, it is a positive side. So since it is the Fibonacci series of minus 1, so you are going to get this 1 plus Fibonacci underscore of series 2 minus 2. So that will going to give you 0. So 1 plus 0 will going to become 1. So what is the, and then he says Fibonacci series dot append next number. So what is the next number? The next number is 1 plus 0 or 0 plus 1 will give you 1. So the next number is 1. Where I want to append that? I want to append that in the Fibonacci series. So fib underscore series dot append. Which number you want to append? The addition of these two numbers, which is 1 and 0. So that is the one which you want to append in Fibonacci series. So once you do that, so what is the next number you're going to get? Fibonacci series is a list containing three numbers now. 0, 1, 1. Why you are getting the third number? Because basically I am appending the next number to the Fibonacci series. So after the completion of this loop, Once its condition becomes false, so it comes return the Fibonacci series. What is that? Returning the results of the Fibonacci series. That is the meaning. Now once you get that, now what I need to do, I want to take the individual Fibonacci series number and square it. So then again, repeat the same principle. Definition, Fibonacci square series of n number. So we are calling Fibonacci n. So that means first I need to Fibonacci series is equal to Fibonacci n. So what you are doing is we are calling the function. So which function we are calling? We are calling the Fibonacci n. So that means this Fibonacci series, what you have, will have the result containing this Fib series. So where num in series, where num underscore series is an empty list, create one empty list. Same principle is used again. For num in series, what is the num series, num underscore series? Initially you have any number? No. For num in Fib series, you don't have any number. So for num in Fib series, so now here for num in Fib series, what is the Fib series you have? 0, 1, 1, 1 plus 1 becomes 2, 2 plus 1 becomes 3, 3 plus 2 becomes 5, 5 plus 3 becomes 8, 8 plus 5 becomes 13, 13 plus 5, 13 plus 8 becomes 21, 21 plus 13 becomes 34. So this is how the sequence will going to go for a Fibonacci series. So num series is 0 because it is an empty list. For num in Fib series, what is that? First number is 0. What you have? So you have to square that. What is the square? Square underscore series will be equal to, what is the first number? 0. 0 double exponential 2. So num series append. Where that num series has to be appended? Which number I want to append? I want to append square series. To append it to what? To num series. So then what happens? The num series will going to have the first number, which is 0. Then what happens? The second one, 1. Is 1 in Fib series? Yes. So number is 1 now. What is the square of that number? 1 square will going to become 1. Then you have num in Fib series 1 because 0, 1, 1. Yes. Square series is again 1, 0, 1, 1. Then you have 2. Is 2 is in num Fib series? Yes. 2 will be equal, num series, square series is equal to 2 to the power of 2, it becomes 4. And this is repeated until the condition until there is no number to be considered from the Fib series. Once you have the 10 numbers, once you want to take the 11 number, it will not be there. So it comes to the return num series. Then we're going to apply the main program. So initially what we have told that I want to give the number. So I want to convert that into integer because whenever you give the input in Python, always it will be considered in string. So since I want to take the number in a integer, so I will say int, convert the string value into integer. Input, enter the number of terms in the Fibonacci series. So what is the condition? If n is less than 1, print, please enter a positive number. By mistake, if you are trying to write a program, when you are trying to select the number, if you give a negative number, so it won't accept. So we need to give the condition for that. So for that, if n is less than 1, colon, print, enter the positive integer. By this you will come to know. Else, what happens? Result is equal to Fibonacci square series n. Print Fibonacci square series of the first n terms, n, print result. So what is the output? Enter the number of terms in the Fibonacci series, 10. Its Fibonacci square series of the 10 numbers is 0, 1, 1, 4, 9, 25, 64, 169, 441 and 1156. How exactly this is behaving, we will going to see now. So first what we are doing is, we are considering n is equal to 10. Here, what we have entered. Enter this number. Next. Is 10 is less than 1. So now we are coming into this. Now we are coming into this. Is 10 is less than 1. Condition is false. So it won't execute this. It comes to this. So else. What happens? Condition is false. Result is equal to Fibonacci square series n. So what happens, you will come to this. Result is equal to Fibonacci square series n. So what exactly it is doing now? We are calling the function now. What is the function? Name Fibonacci square series n. So what we have to do is, we have to go to Fibonacci square series n. Once you go to the Fibonacci square series 1, so now this becomes active. So Fibonacci series, you are calling the one more function. So what is the function? Fibonacci n. Which is the Fibonacci n? The cursor will jumps back to this. Fibonacci series is here, or Fibonacci n will be here. So what is that? Fibonacci series is equal to 0, 1. So this is where you are now at present. Now we will come to this. Fibonacci square series n, calling the function. So once you go to that function, again since you have Fibonacci n, calling function in function. So we have a function of square series and we have a function of Fibonacci number. So now once you go to that, so you are coming to this Fibonacci n. Initially, what is the fifth series? You have 0 and 1. So what is the length of the order? 2. So since you want to go by the negative indexing, so -1 and -2. So while length of the fifth series, the length of the fifth series now is, what is that? The length of the fifth series, length of the fifth series is less than n. So initially, how many numbers you have? 2. So the length of the fifth series 2. Is 2 is less than n is how much? 10. Condition is true. So that is what I am doing now. The 2 is equal to 2. 2 is less than 10. Condition is true. What is the next number? The addition of these two, 1 and 0. So next number is given by fifth series -1 plus fifth series -2. So what happens? So this will become -1 and this will become -2. So -1 is 0. Sorry, -1 is 1. The value of -2 is 0. So it becomes 1. So where exactly now, once you have this, next number I got it. But it is not been appended. But still fifth series you have only 2. That is 0 and 1. I want to add this number. Which is that number I want to add or place it? 1. So where exactly I want to put? I want to put it in list. Where exactly the list? The list is fifth series wherein you have 0 and 1. So since you want to append the list, so I will go for fifth series. What is the list name? Fifth series. I want to append. So append means adding. So append always adds the number at the last item or the last column. So then append. Which one you want to append? Which value you want to append? So next term. So you write next term here. So appended fifth series will be what? Equals 0, 1, 1. Okay. So the addition of these two will going to get this number. Now we'll go to this. So what is the length of this fifth series now? The length of the fifth series is 3 now. Initially it was 2 because you had 0 and 1. Now we have 3 because 0, 1, 1. So is 3 is less than 0, the condition is true. So what is the next number? The next number is fifth series -1 and fifth series -2. This is -2. Fifth series -2. So which is -1? The -1 is 1 and -2 is 1. So 1 plus 1 becomes 2. So then where exactly this next number has to be appended? It is appended to fifth series. So fifth _ series dot append next number. So what is the appended fifth series? The appended fifth series is 0, 1, 1 and 2. Now you can observe here. We had 3, now it has become 4. What is the length of the fifth series? The length of the fifth series is 4 now. Is 4 is less than 10, condition is true. What is the next number? Taking -1 and +2, -1 and -2. So that is 2 plus 1, it becomes 3. So fifth series dot append next number is, appended fifth series is 0, 1, 1, 2 and 3. So this is how it is going to be appended. Now I want to go for the next one. What is the next one? The length of the fifth series. Now here how much we have? 0, 1, 1, 2 and 3. So how many numbers you have? 1, 2, 3, 4, 5. So now the length of the fifth series is 5. Is 5 is less than 10. Condition is true. What is the next number? Fifth series -1 plus fifth series -2. So what is the -1 here? So the -1 is 3 and -2 is 2. So 3 plus 2, it becomes 5. So then again I want to append this number to the fifth series. So fifth series dot append within brackets next num. So what is the appended fifth series? The appended fifth series will be 0, 1, 1, 2. Then I had 3. Then you had 5. Now how exactly you can see 0 plus 1 becomes 1, 1 plus 1 becomes 2, 2 plus 1 becomes 3, 3 plus 2 becomes 5. This is how it will be considered. So what is the length of the fifth series now? The length of the fifth series, previously it was 5. Now since you added one more element to the list, so it will go to become 6. So the length of the length of fifth series is 6. How do I know that? 1, 2, 3, 4, 5, 6. If 6 is less than 10, condition is true. So what is the next number? The next number is this, addition of the last two numbers. What is the addition of the last two numbers? Minus 1 is 5 and minus 2 is 3. So 5 plus 3 becomes 8. So then add that number or append that number to the fifth series. So fifth underscore series dot append next number. Appended fifth series is 0, 1, 1, 2, 3, 5 and 8. So the addition of these two numbers is 5 plus 3 becomes 8. So now what is the total length of the fifth series now? 3, 6, 7. So the length of the fifth series is 7. While 7 is less than 10, yes, condition is true. What is the next number? The next number will be between minus 1 and minus 2. So that is 8 plus 5, it becomes 13. So then you are appended the list of fifth series. What is the fifth series now? The fifth series now will be 0, 1, 1, 2, 3, 5, 8 and 13. Okay. So this is how you will be able to append the fifth series of the total number of length of the fifth series. That is the number of elements in the list of fifth series is 3, 6, 8. So 3, 6, 8 now. So now the length of the fifth series is 8. Is 8 is less than 10. Condition is true. What is the next number? Minus 1 plus minus 2. So what is minus 1? 13 plus minus 2 is 8. So 13 plus 8 is 21. This minus sign what we are getting here is the index of the existing list. Since you are going for the last two numbers, therefore you have to have the negative indexing. Because at every time you are going to get the last two numbers is the last one. You cannot go from the left to right. That is what I wanted to tell. Then once you get the fifth series, dot append to the next number. So what is the next number? You observe here 0, 1, 1, 2, 3, 5, 3. 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 8 is 21. So what is the total length of the fifth series? 3 plus 3 plus 3, it becomes 9. Is 9 is less than 10, condition is true. What is the next number? Fifth series minus 1 and fifth series minus 2. That is 21 plus 13, it becomes 34. So then you say fifth series, append next number. So what is the appended fifth series? So you're going to get the appended fifth series. So what is the total length of the fifth series now? The length of the fifth series is 10. 3, 3, 6 plus 4, 10. Is 10 is less than 10? Condition is not true. So it will going to execute, it will going to come out of the while loop. Once it tries to come out of the while loop, so once it comes out of this, then it should go exit. So it will going to exit the function also. So return the fifth series. Once you return the fifth series, so then what happens? The cursor will come to the Fibonacci square series. So that means the cursor will come to this. So once you are coming out of this return of the fifth series, the cursor will come to this. So in this series we had Fibonacci n. So we have completed this portion. Now it comes to the next one. So what we have done is we have obtained the fifth series, and you take each element from the fifth series and square that and append to one more empty list. So to do that, I will going to create one empty list, that is num series. Now what will going to be the value? Here, since it is empty, no element is found. So for num in fifth series, what is the fifth series says? 0, 1, 1, 2, 2 plus 1 becomes 3, 3 plus 2 becomes 5, 5 plus 3 becomes 8, 8 plus 5 becomes 13. 13 plus 8 becomes 21. And 21 plus 13, it becomes 34. So this is how you're going to have the num series. So that is the fifth series. For num in fifth series, so when you are considering the first element, is there any element in the fifth series? Yes, it is there. First value of indexing. What is the value of that index? The value of that index is 0. So what is the number of that index? The number of that index is 1. So that is 0. Is for num in fifth series, I don't have that number because 0. For num in fifth series, yes. Since there is an element in the num series for the first element, so what is that number? That number is 0. So square series will be equal to 0 square. So what is the result? Result is 0. So you need to append. Which number you want to append? I want to append square series number. Where exactly you want to append? I want to append this to num underscore series. Because at present the num series is 0. Because there is no element in that. So you are appended there. So this is continuous. This is continuous till it becomes false. Let us see now. Now once you have this, so once you get the return num series, so you will come back to this. So this is where we are now. So we have calculated the index of the, you have calculated the Fibonacci series. Now you want to square them. So the cursor comes to the Fibonacci square series. What is the present Fibonacci square is? You have 0, 1, 1, 2, 3, 5, 8, 13, 21 and 34. So I have created a 190 list num series. Is num in fifth series? There is a number in fifth series. Yes, 0. So it is true. So num is equal to 0. Because the value of that index, what I am trying to write here. So I want to square this. So we are taking square series, square underscore series. What is the value of num? Value of num is 0. 0 square is always 0. So then you need to append. Where exactly you want to append? I want to append the value of square series in num series. That is the meaning of this. Num series, num underscore series dot append within brackets square underscore series. So we got the value of square underscore series, that is here. And you are appending that to what? Num series. So what will going to become in num series list now? Previously it was 0. Now it has become 1. So that means there is one element now, which is 1. The element is 0. So you will get 0 here. The value of the square series, what I want to enter here. Okay. Because num series is the empty list. In that I am appending the value of square underscore series, which is 0. Then again, since it is a loop, so again it goes back and checks. Is for num in fifth series? Yes, there is a number here, 1. So what is that number? Num is equal to 1. What is square series? Num to the power of 2. So 1 to the power of 2, it becomes 1. So append that square series to where? Append the square series to num series. So num underscore series dot append square series. So what happens to the num series now? Previously it was 0. Now it has become 1. 0 and 1. Then again num in fifth series? Yes, because there is 1. So what is the value? Num is equal to 1. What is the square series? 1 square. So you're going to get 1. So you append that where? To num series. So in the last this thing you can see num series dot append square series. So num series will be equal to 0, 1, 1. Then we'll go to the next. So is there num in fifth series? Condition is true. Yes, you can see here there is a number 2. Num is 2. Square underscore series num square, that is 2 square 4. Then append that with number square series to be appended to num series. It's an empty list. So the num series will be 0, 1, 1, 4. Similarly, num in fifth series? Yes. Num is equal to 3. Square series is 3 to the power of 9, 3 to the power of 3 square, which becomes 9. So you append that. So what happens? Now you can see 0, 1, 1, 4, 9. Then is num in fifth series? Yes, definitely it is there. Condition is true. That is num is equal to 5. Find out the number square of that number, 25. Append that to num series. You'll get 0, 1, 1, 4, 9, 25. Similarly, the num in fifth series 3. True. Condition is true. Num is equal to 8. So square series is 8 square, which becomes 64. Append that to the num series. So what will going to happen now? 0, 1, 1, 4, 9, 25. Previously it was 25. You are appended that after calculating the number and squaring that, 64. So again, is num in fifth series? Condition is true. So you'll get 13 num. So 13 square is 169. Append that. So you can see 169. Then is num in fifth series? Condition is true. So num is equal to 21. So what is the square series? Square series is equal to num square. So that is 21 square. You will going to get 441. So append that num series. So what is the num series? 0, 1, 1, 4, 9, 25, 64, 169, 441. Then again, is num in fifth series? Yes. Condition is true. Num is equal to 34. So square of that number is 1156. And append that to the num series. The num series will be 0, 1, 1, 4, 9, 25, 64, 169. And then you will going to have 441, 1156. So that is the number. So once you do that, so once you have the 34 number, after that you have any number in series? No. You don't have any number. So num in fifth series becomes false. Once it becomes false, so return the num series. Where exactly you want to return? They return the num series to the main function. You can see here. The return to this is return num series. Where exactly you want to return? You want to return the num series. You want to return the num series. Then, so once you want to return the num series, so you are going to get the values of num series. Going to get the values of the num series. So result will be equal to Fibonacci square series n. Okay. So num series we are going to get here. So the num series what we have is the square of each Fibonacci series number. So you got the square of each Fibonacci square series number. So the entire list comes here directly. And once you come, it comes directly to this. So here, that is what we have saying, Fibonacci square series n number. So what is the return value? The return value of the num series is this value, what I am trying to return. So once you do that, so print, give the print function to print the numbers after getting square. So the result will going to be the one which will going to print in the final value. So what is the output you are going to get? The output will be enter the number of items in the Fibonacci is 10. The Fibonacci square series of the first 10 numbers will going to give you this value. So this is how you will be able to get the Fibonacci square series of the number. Now what we need to do is we need to write a simple program. So to do that, first I will go for def Fibonacci n. Then fib underscore series equals, first you can keep two numbers 0 and 1, while length of fib series is greater than, is less than n, is less than n. Next num will be equal to fib underscore series. It's a list, so we are giving the index numbers, that is -1 plus fibs underscore series -2. Once you get this number, then I need to append. What is that append? Append to what? fib underscore series. So I go for fib underscore series dot append. Then you'll go for next number. Once after getting this, what I need to do, I need to print the result. So I will go for return fib series. Fib underscore series. Now once you do that, now we will go for the definition of the another one. So def Fibonacci underscore square underscore series. Okay. Once you do that, fib series is, I will consider fib series. I am calling the function now. What is that? Fibonacci n number. Once you do that, now I will say num underscore series. What is the num series? I will create an empty list. Once you do that, then for num in num underscore series, for num in num series, square series square underscore series equals, what is the number? Num double star 2. Once you get this, then you want to append. I will append what? Num series dot append. Num series dot append. What you want to append? I want to append the square series. Then I need to return this. If the condition becomes false, then I need to return num series. So once you do that, now you will go for the program. Let n will be equal to int input. Then enter the number of terms in the Fibonacci series. Okay. Once you do that, then what I need, if n is less than 1, print. Please enter the positive number. Else, I don't want that. Then what you are going to get? Result equals Fibonacci square Fibonacci square series n number. Correct? Once you do that, print Fibonacci square series of the first term. Of the first comma n comma terms colon comma end equals given space, end equals given space. Then I want to print what? I want to print the result. So this is how we will be able to write the program. I will go to this. So now first we are going to check how we will be able to get the answer. Later on we will go by step. I will go for 10. So you are going to get the number 0, 1, 1, 4, 9, 25, 64, 169, 441 and 1156. Now we will going to apply that for a very small number so that I will be able to show you how exactly it will going to behave. Now we will come to this. So first I will call that function Fibonacci series. I will say 5. So now is 5 is less than 1, condition is false. Result will be Fibonacci square series. What we are doing is now we are calling the function. Which function we are calling? Fibonacci square series. Now the cursor will go to jump to this now. So it comes here. Fib series, Fibonacci here. So since you are calling the Fibonacci series, because I need to find out what is the sequence first. So it goes to this now. So here, Fib series. So what is the Fib series? You have 0 and 1 first. So length of the Fib series is 2 now. So you can see the length of the Fib series is 2. Then length is 2. What is the next number? Minus 1 and 1. So that means minus 1, that is 1 and 0. So it becomes Fib series. We're going to have next number is 1. So now you need to append that to Fib series. See here what happens. It becomes 0, 1, 1. So it becomes this. Next, what is the length of the Fib series now? It becomes 3 now because you have 0, 1, 1. So you have 3 elements. So you go to that. So what is the next number? 2. So append that. So you're going to get 2 now. So what is the length of the Fib series now? It becomes 4. Okay. Is 4 is less than 5. Condition is true. Then Fib series we're going to have 3 now. So then you have 5 elements. Is 5 is less than 5? No. Then it comes to this. What is the Fib series you have? Fib series what you have is 0, 1, 1, 2, 3. So return Fib series. Where it will go to return Fib series? That Fib series will going to come to this now. So whatever the value we had here, that has come to this now, Fib series. So Fibonacci is same. Now what we are going to get is, I want to create an empty list. So I will go to an empty list. So we have Fib series is this number. Fibonacci sequence is that. So num series initially it will going to take empty. For num in Fib series, is there any number in the Fib series? Yes. So num value is 0 here. So num value is 0. So square of that 0 will be 0. Num is 0. That is square series is 0. So you want to append. What append? The square series number to the num series. What is the num series value? Initially now you can see there is 0. So that will be appended to here. 0. Then for num in Fib series, what is the number now? 1 is there. So you take 1. So num will become 1 now. 1 square becomes 1. So that is get appended here. Then num in Fib series, yes. Square of that number again 1. So you are appending that also. Then num in Fib series is 2. 2 square becomes 4. That you are appending. Then num in Fib series 3. 3 square is that 9. Then you append that number to the num series. Then afterwards, is there any number? No, you don't have any other number. Comes out of this. Return num series. What is the value of num series? The num series is 0, 1, 1, 4 and 9. So where exactly it will go to return? The return will come to the result. So what is print? Fibonacci square series of n terms. N terms is how? 5. Is this. So you come to this now. So once you come to this, print. So it comes to Fibonacci series of the first n terms. Since you have the n parameter or end word, so it will continue on the same line. So I want to print the result. What is the result? The result will be Fibonacci square series of n numbers. What is the Fibonacci square series of the n numbers? 0, 1, 1, 4, 9. So the result value what you will going to get print here is 0, 1, 1, 4 and 9. So this is how the Fibonacci square series works in Python program. Thank you.